The notion of a repeating block of code, or in other words a loop, is fundamental to just about every programming language. The Bourne shell does indeed support loops. In fact, it offers two different types of loops, what we call the while loop and the for loop. If you've ever programmed before in another programming language, say for example C, then you'll be very familiar with the notion of a while loop, and you'll probably be also familiar with the notion of a for loop, but the way the Bourne shell implements the for loop is actually somewhat different to what you might be used to. So if you were planning to skip over this chapter because you already know loops very well, I wouldn't skip over the module on the for loop. It is a little different to what you might expect. Also in this chapter we discuss the notion of arithmetic. We find out the way in which we can actually implement arithmetic using the shell. That's in the module on EXPR. Anyway, let's begin. We'll start with the while loop. If you're very comfortable with the if statement and the way it conditionally executes a block of code, then you'll probably be fairly comfortable with the while loop. It's very similar to the if statement. It actually just simply repeats the execution of a block of code in the same way that the if statement conditionally executes the block of code, in other words, based on the exit status of one command at the top of the loop. And it looks like this. We start with the line while command, and that actually means while this command continues to return an exit status of 0, in other words true, then do the following. We have the word do on the next line, on a line by itself, and then we have the code block, which can of course be as many lines of code as you like, followed by the word done, which is a little inconsistent from the if statement, which actually just reverses the word if and calls it phi, in the same way case becomes esac and so forth. And as I said before, the code block just simply executes repeatedly until the command at the top returns an exit status that is non-zero. Let's have a look at a little example of that. You might use the while loop to read an answer from the keyboard and keep reading the answer until they answer something that is valid. Or in other words, while they continue to answer an invalid answer, you get them to try again. So here we might read an answer, and then we use the test program to test whether the answer that they entered happens to be equal to the correct answer, which might in this case be chickens. And if it's not, then we can execute a code block which would echo out some kind of error message and ask them to do it again. I'll show you another example now. I'll demonstrate an example that's perhaps a little bit more useful. Here's a very simple implementation of the while loop that can be used to make sure that the user actually entered a valid directory name when a directory was required. You simply ask them to enter a directory and then you test it using of course the test program, the open square bracket, and if it is not a directory, then you can print out an error message to that effect and ask them to enter that again, and that will keep going around and around and around and around in that loop until such time as they enter a valid directory name, at which point it will drop out to the bottom and echo out the word congratulations. Now, the block of code between the do and the done may never get executed because the directory that they enter the very first time may actually be a directory. So let's have a look at that running. I'll run that now. Please enter the name of a directory. Well, I'll just type in some garbage there. Okay, that's not a directory. Please try again. And if I just press enter by itself, okay, so that's empty is not a directory. Please try again. I'll just type in /temp, and that is a directory. So that is clearly working. So there's really not much to the while loop. It's quite simple. If you understand the if statement, then you probably understand the while loop. It's actually simpler than the if statement because it doesn't have an else clause or an elif or anything like that. But there is actually one interesting, shall we say, advanced thing that you can do with the while loop, which I'll just show you now because it is very, very useful at times. It's actually possible to get a while loop to process each line of the output of a given command. In other words, to execute the code block once for each line of the output of the command. Let's have a look at an example of that. The command in this case might be the who command. So you can actually take the output of a program, like who, and pipe it to a while loop as long as the condition that you're testing in the while loop is actually a read statement. The read statement will continue to read one line at a time from the output of the who program until it reaches the end of the output, at which time it will return false. Now the data in the who program is comprised of 3 columns: the username, the terminal they're on, and the time that they logged in. So I can read the data from that line into 3 different variables: user, term, and time, and then I can simply echo that out. User has been on term since time, or I can process that in any way that I like. That is an extremely useful construct. It's a little bit difficult to get the syntax right and to remember how it goes, but if you can refer back to this, it's very, very useful. Okay, so that's it for the while loop. Pretty straightforward stuff. There are 2 extra keywords in the shell programming language that are used to control the execution of a loop. And when I say a loop, I mean actually any kind of loop, not just the while loop. They can also be used in conjunction with the for loop. Those keywords are break and continue. So let's have a look at them. We'll firstly look at the break. Using the word break is a way to actually cause a loop to immediately terminate. Sometimes having a single termination condition at the beginning of a loop is not enough. Sometimes you need to have several termination conditions. There may be several situations in which you want to break out of a loop. So you can put the main one at the top of the loop, like while such and such is true, and then inside the loop you could have perhaps a series of if statements. If this situation is true, then break. In other words, terminate the loop. It's a very useful little option at our disposal. Continue is kind of the opposite. It will actually cause us to go around the loop again. In other words, any remaining code in the code block just simply gets skipped. We go around the loop one more time, and the loop condition right at the top of the loop, the while such and such is true, does in fact get retested. So the continue is simply a way of skipping a bunch of code, skipping the code that follows the continue line inside the code block of the loop. I think the best thing to do at this point is to have a look at an example. So let's do that. This block of code assumes that the user has just typed in some data into a variable called filename, and you can see that the last line of the loop is getting them to read another file name as well. So effectively we'll continue to go around this loop while the user continues to type something in response to the read command. So what does a loop actually do? Well, it assumes that the file name that they typed in is supposed to be a directory. So the very first thing that we do is we test to see whether it is, and if it's not a directory, then we simply continue, which means that we skip everything after the word continue all the way down to the done and go right back around to the while file name. Now the sharp people amongst you may see that we've actually got a bit of a problem here, because what we would want to do just before we continue is read the name of the next file name or the next directory name to test. Otherwise we're going to have an infinite loop, because we'll just go round and round the loop and we'll say while file name, and that will still be set. So we'll go and say, okay, is it a directory? And it still won't be a directory, and we'll just go around and keep doing those 2 tests over and over again, because the file name variable is not changing. So if you like, that's a little bug in this little code snippet. Nevertheless, the principle is correct, and the principle is that if it is not a directory, then simply skip whatever processing is involved next by use of the continue statement. So if we get past the continue statement, if we get to the phi and the next if, then we must have a directory at this point. So now we can do a little ls of that directory, pipe the results to wc-l, which will give us the number of files in that directory. Now we enclose all that in backwards quotes, so let's say there are 25 files in that directory. The backwards quotes and everything inside them gets substituted with the number 25, so we simply do a test if 25 is greater than 100, which in that case it wouldn't be, but if it was, if we ended up with 125, then maybe that's some termination condition, that's some error. If we ever get to a very, very large directory, then we stop processing altogether. So we would echo out a message to that effect: we are stopping, there was a huge directory, huge being contents greater than 100, and we break. We don't read any more information, we don't go around the loop again, we don't do any more testing, we just simply continue on with the next line of code after the word done, if there are any. So, assuming that we make it past the continue, which means that it is definitely a directory, and we make it past the break, which means it wasn't a huge directory, then we can process that directory as normal. So obviously there would be some code in there at that point that does whatever we need to do with this particular directory. So in general, I guess you could say that the continue is used to skip over invalid situations in a loop and make sure that we only process valid ones, while the break is used to terminate the loop altogether should some termination condition arise other than the one right at the very top of the loop. So that's about it. Break and continue. They're not actually that complicated. It's just a matter of getting used to their